Question 4a, circle has equation x squared plus y squared minus 4x plus 10y minus 8 equal to 0. Determine the center and the radius of the circle. So we need to write it in the completed square format. So let's group the x. So we have x squared, we have minus 4x. We have y squared, positive 10y. This minus 8, we can take it over to the right hand side. So let's complete the square now for the x terms. So x, split the b in 2, minus 2 square, and then minus, notice when you expand, you have x squared minus 4x plus 4. So we subtract the 4 because we only need x squared minus 4x. This term, so y squared, split the 10, we get 5. Notice when you expand, you get y squared plus 10y plus 25. But of course, we only want y squared plus 10y, so we subtract the 25 equal to 8. And we can add 25 and 4 to both sides. So we end up with x minus 2 all squared plus y plus 5 all squared is equal to 8 plus 25 plus 4. So we end up with x minus 2 all squared plus y plus 5 all square. So 8 and 25, that's 33. 33 and 4, that's 37. So the center of the circle, so the center of the circle is the values that makes the bracket 0. So 2 for the x and for the y, minus 5. And the radius is square. Remember, r square equal to 37, which means that r is equal to the square root of 37. Which is 6 point something. We can leave it as in the third form, root 37. Next, we are asked to determine the equation of a tangent which touches a circle at 311. Let's do a sketch. So here's a circle. This is the center. Where at the center we have 2, negative 5 as a center. So a line that goes to the reader. The tangent will look something like this, right? The tangent is a line that touches the circle only once, so it's a straight line. We're told it touches the circle at the point 3, 11. So we want to find the equation of this tangent line. And the equation of a tangent is in the form y equal mx plus c. So for the tangent we need a gradient. But first we need a gradient for the radius. Let's find the gradient for the radius. So gradient for the radius is, we can use y2 minus y1 upon x2 minus x1. So here we can call this x1, y1, x2, y2. So the radius would be 11 minus 5. So we end up with 11 plus 5 upon 3 minus 2. So we end up with 11 and 5, that's 16 upon 1, that's r. So we end up with gradient of r, so the gradient of r, let me just, gradient of r, not r, the gradient of r is equal to 16. So this gradient is 16. Notice from circle theorem, the angle between the radius and the tangent is always a right angle, 90 degrees. So this gradient, the radius, is 16 or 16 upon 1. So the gradient of the tangent, which is perpendicular, would be negative 1 upon 16. So for the tangent, remember the tangent is a straight line. All straight line can be written in the form y equal mx plus c. So we need to get the value of c. So we know the tangent line, it passes through 311, this point, that's the line, 311, that's where it touches the circle. And m for the tangent, m is negative 1 over 16. So substitute 311, x is 3, y is 11, so replace y with 11. M is negative 1 over 16. X is 3. Plus c. So solve for c. So we have 11 plus 3 over 16. This is negative 3, 16. Bring it over. positive 316. So C is 11 plus 3 over 11 and 316. And I guess you could write that as improper fraction, 11 and 316, 16 times 11. So plus 3, we end up with 179. 179. So C, RC equal to 179 upon 16, if you want to write it as an improper fraction. So therefore equation of tangent, therefore equation of tangent is, of course, y equal mx plus c. So is y, the m is 179, the m is minus 1 over 16 times x plus c, which is 11 and 316, or 179 over 16 if we are using the improper fraction. Show that the curve whose parametric equations are 3 plus 3 sine theta and y equal 3 cos theta represents a circle. Now, for this equation, let's transpose for sine theta. If we have x equal to 3 plus 3 sine theta, we can subtract 3 from both sides, so we end up with x minus 3 equal to 3 sine theta. Divide both sides by 3. So we're left with sine theta is equal to x minus 3 over 3. And if we square both sides, let's square both sides. If we square both sides, so square both sides, we end up with x minus 3 upon 3 all square, which is sine square theta. Over here, on the other hand, we have y equal 3 cos theta. If we divide both sides by, this one, if we divide both sides by 3, y over 3, so that would be equal to cos theta. So from this equation, cos theta is y over 3. If we square both sides, y over 3 all square is equal to cos square theta. Now, recall a very famous trig identity, and I recall that cos square theta plus sine square theta is equal to 1. Now, from here, cos square theta is y over 3 all square, and sine square theta from here is x minus 3 upon 3 all square. And so cos square plus sine square equal to 1. So it's just basic substitution. So when squaring a fraction, we square numerator and denominator. So square y over 3, we get y square upon 3 square, which is 9. And square numerator is x minus 3 all square upon 3 square again, which is 9, equal to 1. So we can times both, let me just times both sides by 9, times each term by 9. So we end up with 9 times, so 9 times this term, 9 times this term, and 9 times 1, right? On the right hand side, 9 times 1 is 9. Over the left hand side, 9 times, here, 9 cancel 9, so we're left with y square. And here, 9 is 1 again, so left with x minus 3 upon square. X minus 3 all square. Notice there's a circle. Notice you can rewrite the y square as y minus 0 if you wish. There's no need to, but just to get it in the form x minus a square b y minus b square equal to 9. All right. Notice in this form of an equation of a circle, and this circle, the center of the circle, or the center of the circle, the values that make the bracket 0, for the x is 3, and for the y is just 0, right? And the radius of the circle, notice r square is 9, r square is the form, so, and hence r is equal to positive 3. So it's in the format of an equation of a circle, so we know it's a circle. Part C, two position vectors are represented as OA and OB. Let me just call this U and V. Find the angle between OA and OB. We can say let the angle be theta, and we know that cos theta is U dot V, so it's the dot product or the scalar product of the two vectors upon the modulus, the product of a modulus. So modulus of U times the modulus of the other vector, V. So U we call in OAU, so cos theta, from here cos theta would be equal to 1, 2, 3. That's one vector times the other vector, 1 minus 3, 2. Upon the modulus of U will be the square root of 1 square plus 2 square plus 3 square. So 1 square plus 2 square plus 3 square. Times the modulus of the other vector, which we call in V or OB, is same 1 square plus 3 square plus 2 square. So 1 square. And then negative 3 square, same as 3 square, going to be 9, right? So it doesn't matter, plus 2 square. So we end up with, let's do that product now. End up with cos theta is equal to, they put it now, 1 times 1, which is 1, plus 2 times minus 3, that's minus 6, plus 3 times 2, that's positive 6, upon the square root of 1 plus 2, 1 plus 4 plus 9, 1 plus 4 plus 9, that's what, 14, and 1 square is 1, 2 square is 4, 3 square is 9, and at the other term have the same thing, 14. So hence, cos theta, so negative 6 plus 6, that's 1, so it's 1, and root 14 times root 14, that's 14. So theta would therefore be cos inverse 1 over 14, which will give us, if I'm using 1 decimal point, that's 85.9 degrees. Determine the vector equation of a plane which passes through the point 2, 5, 3 and is perpendicular to the vector 4, 4, minus 1. So 4, for use the coefficients for I, j, k, 4, 4, and it's of course minus 1k. Let's use the formula, equation of a plane, Rn equal to An. So this is equation of a plane, so standard formula, equation of a plane. Of course, where R is x, y, z, N is a normal or the perpendicular vector, which is 4, 4, minus 1. And A is a point in the plane, which we have 2, 5, 3. So this should be A. This should be AN, right? And A represents a point. Alright, so which is 2, 5, 3. And again, the normal or the perpendicular vector, 4, 4, minus 1k, right? So doing the calculation, x times 4, that's 4x. 4 times y, so we're taking a dot product. And z times minus 1, so minus z, equal to dot product on the right hand side. 2 times 4, that's 8. 5 times 4, that's 20. 3 times minus 1, that's minus 3. So we end up with 4x plus 4y minus z. 8 and 20, that's 28. Take away 3, that's 25. And that completes our solution for part D. So we now move to question 5, which is integration by substitution. So using the substitution, u equal to x cubed plus 4, we are told. And let's find du by dx. So du by dx would be equal to 3x squared. Right, 3x squared. Let's make the substitutions in here now. So we're doing this problem. Let's make our substitution. This is what we're integrating. 3x squared. Now note we are told to use u equal x cubed plus 4. So x cubed plus 4, we'll replace that with u to the power of 4. So what's in the bracket is equal to u and to the power of 4. Now 3x squared dx. Now if we look at this differentiation with it here, if we should cross multiply here, we end up with du equal to 3x squared times dx. So 3x, this 3x squared and times this dx can be replaced with du. So that's how substitution works. You want to get rid of all the x variables and replace them with terms in u. Alright, continuing. So let's integrate. Integration, add 1 to the power, divide by the new power, plus c. So integrating u to the power of 4, we get u to the power of 5, divided by 5. And we can simply replace now. Remember, u, what's u? X cubed plus 4. So u replaced with x cubed plus 4 to the power of 5 upon 5 plus c. You put the plus c because it's an indefinite integral, meaning there are no limits. Now let's look at what part B is asking us to do. Calculate the area enclosed by the parabolas y equal x squared. So we can see clearly this is a graph of y equal x squared. It's a popular graph, and the other graph, obviously this one would have to be 6, the other one, which is 6x minus 3x squared. Now to calculate the area enclosed by the parabolas, it's very important. We need to get the limits. So of course we need to find the point of intersection for these two graphs. To get the point of intersection, notice one is saying y equal x squared. The other one, is y equal 6x minus 3x squared. So let us solve simultaneously. So we solve simultaneously to get this point of intersection, the points of intersection, which would be here and here. So y equal x squared, y equal 6x minus 3x squared. So we can use substitution and conclude that 6x minus 3x squared is equal to x squared. So both of them are equal to each other, since both of them are equal to y. So let us group. If I group, let me group everything on the right hand side. So I have x squared plus 3x squared and minus 6x. So I don't know, x0 is 4x squared, so it's 1x squared plus 3x squared, that's 4x squared, minus 6x. 0, I can factorize. The common factor here is what? 2x. For factor 2x, in the bracket here I would have 2x again, and minus 3. And of course I can equate both brackets to 0. So therefore 2x equal to 0, or 2x minus 3 is equal to 0. Solving each of them, divide by 2, x equals 0. And the other one, 2x equal to 3. Divide both sides by 2. X equal to 3 divided by 2, which is 1.5. Alright, so notice here x is 0, right? And here x is 1.5. So we don't really need the y values, just the x values. So x is 0 and also 1.5. Now to find the area, this area we find in the area enclosed by circles. Alright. So the area enclosed by both graph would be, remember integration give us area on the graph. So the area, let me just put it here. Where can I put it? So the area of the region enclosed by the parabolas. So area of the region enclosed by the parabolas would be the integral. Now if we take the integral of this one, y equals 6x minus 3x squared. minus the integral. What we just did a while ago, integral of 6x minus 3x squared would be the area under, all the area under this graph, right, between the parabola and the x-axis. I will subtract it now from the area beneath x squared, which will be this, so it will leave us with the integral, with the area in question, the area enclosed. So minus the integral of x squared. Remember, integration gives your area. And the limits, now the x limits is same for both of them. So for this, both of them x limit from 0 to 1.5. So from 1.5, or let me use 3 over 2, same as 1.5, 3 over 2, 0. Alright? And of course, certainly, we can just use one integral, so 6x minus 3x squared minus 1x squared, so end up with minus 4x squared actually, and the limits doesn't change, 0 and 1.5, or 0 and 3 over 2. Alright, dx of course, since we're integrating with respect to x. Alright, so we can just combine in one integral, and with 3x minus 3x squared minus x squared, we end up with minus 4x squared. Of course, dx. So the integral, integrate 6x at 1 to the power, you get 6x squared, divide by 2, you get 3x squared. For the other one, at 1 to the power, you get x cubed, divide by 3. Alright, between 0 and 1.5. So now let us make our substitution. Do I have enough space? I'm running out of space. Let us make our substitution. So we form two brackets. In one bracket, you replace x with 1.5 or 3 over 2. In the other bracket, you replace x with 0. Now when you replace x with 0, everything is going to become 0. So it's really just, replace x with 0, everything will become 0. So it's really just 1.5. Alright, so or 3 over 2 if you prefer. So that's 3 times 1.5 square, or 3 over 2 square, minus 4 times 1.5, let me use 1.5 instead of the 3 over 2. So 1.5 square minus 4 times 1.5 cube divided by 3. So that would be the first bracket, substitute in 1.5. And minus, you substitute 0 for x, and you'll end up with 0. So let me just finish the question over here. I'm out of space, let me just finish it over here. So 3 times 1.5 square is equal to 6.75, that's straightforward use of the calculator, minus 4 times 1.5 cube, so it's 4 times 1.5 cube, divided by 3, we end up with 4.5. So it's now 6.75 minus 4.5. We end up with 2.25 square units. Can I talk about the area? So remember it's square units. So 2.25 square units, or 2 1/4. The equation of a curve is given as f of x is 3x to the power of 4 minus 4x cubed minus 12x squared plus 1. Show that f of x has stationary points, and we are given 3 different values of x. Now, stationary points, so stationary are turning points. Stationary points, that's not how we spell points. So stationary points occurs when, of course, when dy by dx is equal to 0. Now let's find dy by dx. Integrate f of x, we get 4 times 3, that's 12, so 12x cubed minus 12x squared minus 24x equal to 0. So that's dy by dx. To simplify, we can divide each term by 12. We can divide each term by 12, so we end up with x cubed minus x squared minus, divide this by 12, we get 2 x equal to 0. Of course, we can factor out x. So factor out x, we get left with x squared minus x minus 2. Factorization there, since x was a common factor. And the quadratic there, we can factorize. Notice to factorize this quadratic, we think of two numbers that add to give minus 1 and multiply to give minus 2. That's minus 2 and positive 1. These numbers add to give the middle term, which is negative 1x, and we multiply them, we get minus 2. So if we equate both brackets, all the brackets to 0, we have x equals 0, we have x minus 2 equals 0, and we have x plus 1 is equal to 0. Solve each of them. We already solved this one, x equals 0. So here x equal to 2, and the other one x equal to minus 1. So we just prove the solutions. The stationary points occurs when x is 0, 0, 2, and negative 1. Let's go down to see what else is required of us. Determine the nature of these stationary points. In other words, you want us to tell whether these stationary points are maximum or minimum or points of inflection. Now, let me just rewrite dy by dx. We found that dy by dx was equal to, let me just recap what dy by dx was. dy by dx was this, so we differentiate it from f of x, we end up with that. 12x cubed, 12x squared, 24x. That was dy by dx. So to tell the nature, we need the second derivative. So d2y upon dx squared. We end up differentiate this, we get 36x minus 24x minus 24. Alright, remember what the x values were? The x values were 0. Let me remind ourselves what the x values were. The x values were 0, 2, and negative 1. Negative 1, 0, and 2. Now to tell the stationary points, the nature of the stationary points, meaning whether it's a maximum or minimum or a point of inflection, we need to find the second derivative. Remember the first derivative was 12x cubed, 12x squared, 24x. So the second derivative, we get the second derivative by differentiating the first derivative. So we end up with 36x squared minus 24x minus 24. So remember the x values were, let's remind ourselves of what the x values were. Minus 1, 0, and positive 2. So when x is minus 1, the second derivative, substitute minus 1, so it's 36 times positive 1, because you square negative 1, you get 1. So it's just 36. And then negative 24 times negative 1, that's positive 24. Take away 24. Leave us with 36, which is greater than 0. And once the second derivative is greater than 0, that's a minimum point. When x is 0, that was the other x value, the second derivative, it should be easier to calculate. When x is 0, the second derivative, you substitute 0 for the x, you're left with negative 24, which is less than 0. And when the second derivative is less than 0, that's maximum, is it? A maximum point when x is 0. When x is positive 2, the second derivative, replacing the x with 2, the second derivative is 36 times 2 squared, which is 36 times 4, right? Minus 24 times 2, which is, what's 24 times 2? That's 48, minus 24. So 36 times 4 minus 48 minus 24. I'm not sure what the value is. You can do the calculation, but this value is certainly greater than 0, therefore minimum point. So notice this function has two minimum points. and one maximum point. So it's minimum when x is negative 1 and when x is 2. It's a maximum when x is equal to 0. And now the sixth and final question. So we have a piecewise function there. So the first piece is in the domain when x is less than 1. The second piece, the function is equal to 2 when x is equal to 1. And the final piece, x squared minus 1 upon x minus 1. For the domain x is greater than 1. Determine whether or not the limit of f of x exists as x approaches 1. So now we want to test if the limit exists as x approaches 1. So the left hand limit should be equal. So the left hand limit, which would be limit as x approaches 1. Left hand limit should be equal to the right hand limit. That's what we want to prove. So left hand limit, well, let's find left hand limit first. So left hand limit, which we use in the first piece, 2x plus 3, left of 1, that's when x is less than 1, right? So the limit, that's the limit as x approaches 1 for the piece 2x plus 3. We substitute 1, you get 2 times 1, 2 plus 3, 5. So the left hand limit is 5. Let's find the right hand limit now as x approaches 1. So the right hand limit as x approaches 1 from the right. So it is the piece for when x is more than 1 to the right of 1 on the number line. So we end up with a limit as x approaches 1 for x squared minus 1 upon x minus 1. And to find this limit, we can factorize numerator and we end up with the differential squared. That's x squared minus 1 squared. So that's x minus 1, x plus 1 upon x minus 1. Notice x minus 1 into itself. Let's cancel. I have 1 here. We substitute 1. We end up with 1 plus 1, 2. So you'll notice that the left hand limit, which was equal to 5, is not the same as the right hand limit. So therefore the limit does not exist. Is it continuous at x equal to 1? Not continuous. Since the limit does not exist at x equal to 1. Part B, the parametric equation of a curve is given as x equal to 5 cos theta and y equal to 2 sin theta. Find dy by dx. So dy by dx is dy by d theta divided by dx by d theta. Now dy by d theta, that's 2 cos theta, differentiate 2 sin theta, we get 2 cos theta, and differentiate 5 cos theta, that's dx by d theta, differentiate 5 cos theta, that's minus 5 sin, differentiate cos is minus sin, right? Minus 5 sin theta. That's dy by dx. Part C, given that the integral of f of x between 1 and 4 is 10 over 3, the integral of the same function between 2 and 1 is positive 2, and we are told that g of x is positive root x. Now we are asked to evaluate the integral of f of x plus g of x, alright, between 4 and 2. So of course we can break this up. So this can be rewritten as the integral, same limit of f of x, so we break it up, f of x dx plus the integral of g of x dx between same limits 4 and 2. Now let us try evaluate this integral. Now do a look at sketch of a function. Let me do a sketch. Where can I put it? Let me do a sketch here, right? So let's say we have a function. This is y, this is x, where the meet is 0. Let's say we have a function f of x. Alright, this is f of x. Now the integral between 1 and 4, so the limits here in question 1, 2, and 4. So x is 1, x is 2, x is 4. The integral between 1 and 2 give us the area under the graph. 1 and 2, the integral between 1 and 2, we are told is positive 2 here. The integral of f of x between 1 and 4, between 1 and 4, that's all of this between 1 and 4, we are told it's 10 over 3. So in other words, when you add the area of this under this graph and the area in this graph, we should get 10 over 3. Alright, so I guess this 10 over 3 is what? That's 10 divided by 3, that's 3 and 1/3. That's 3 and 1/3. So this would have to be 1 and 1/3. The integral between 1 and 4, we're told the integral between 1 and 4 is 3 and 1/3, 10 over 3. Which means that the integral between 1 and 4 is 3 and 1/3. So if this section is 2, then this section would have to be 1 and 1/3. So the integral between 4 and 2 would have to be 1 and 1/3. Or we could say, let me put what I have, we could say integral between 4 and 1 dx, which is 10 over 3, minus the integral between integral of, one of the additive properties of integration, plus, by the way, so this second one, g, we know g is the square root of x. G is the square root of x, which can be written as x to the power of half, right? So the integral here in question, integral of f of x between 4 and 2 is actually 1 and 1/3, or 4 over 3, right? So all of this will equal to 10 over 3 minus 2. And 2 is 10 over 3 minus 2. So that's what's that come to? Plus this piece now integrate half, or we integrate again. Add 1 to the power. Add 1 to half, we get 3 over 2, or 1.5. Divide by the power, so divide by 3 over 2 is same as multiplying by 2/3. Right? Between the intervals 4 and 2. So this is 10 over 3 minus 8 over 3. Or should I say 6 over 3 rather? Times 3 times 3. So it's 10 over 3 minus 6 over 3. That's 4 over 3. Or 1 and 1/3, which is what we have here. Alright. Plus, let's work out these limits now. So in one bracket we substitute 4. So it's 2/3 times 4 to the power of 3 over 2 minus 2/3 times 2 to the power of 3 over 2. So we end up with what now? So this is 4/3 plus 4 to the power of 2 over 3. Now 4 to the power of half, that's 2 cubed, that's 8. So it's 8 times 2/3, that's 16 over 3. Minus 2/3, the square root of 2, the square root of 2 to the power of 3. So the square root of 8, right? So this can be written as the square root of 8. So we can make the common denominator be 3, right? So 4 and 16, that's 20 minus 2 root 8. So that's our solution. Part D, solve the differential equation dy by dx equal sine x over sine y. We can cross multiply right away. So if I cross multiply, I get sine y times dy equal to sine x times dx. And of course, we can integrate both sides. Sine y times dy. Sine x times. And of course, we can integrate both sides. Integrate sine y, integrate sine y, we get negative cos y. And integrate sine x, that's negative cos x plus c. Now we are told that x is 0, when y is pi over 2, so we substitute x equals 0 and y equal to pi over 2. That's 90 degrees alright, so x equals 0. So cos pi over 2, replace y with pi over 2, replace x with 0, so it's minus cos 0 plus c. Now cos 0 is 1, so that's minus 1 plus c. And cos pi over 2, that's cos 90. That's 0. Cos 90 is 0, right? So transpose c is equal to 1. Right, so therefore, from here, minus cos y equal minus cos x plus c, which is 1. And so we can transpose for y. To transpose for y, we can times both sides by minus 1. So we can times both sides by minus 1. So minus 1 times the left hand side, that's positive cos y. And minus 1 times the right hand side, we get positive cos x minus 1, which means that y is equal to cos inverse cos x minus 1. That's our solution. In the final section, determine the equation of the curve that passes through 1, 5 and for which y is equal to the integral of 6x squared dx. So let's integrate 6x squared. So y integrate 6x squared, we add 1 to the power, we get 3 divided by 3, and of course we add c. So y is equal to 2x cubed plus c, and to get the value of c, we substitute the point, which is 1, 5. So we substitute 1, 5. X is 1, y is 5 to find the value of c. So replace the y with 5. Replace x with 1, so 2 times 1 cube plus c. And 1 cube is 1, so to find the value of c is 5 minus 2. So therefore the value of c is 3. Right? C is equal to 3. So therefore the equation is y equal to 2x cubed plus c, which is positive 3. And that's the end of the paper.